Good morning. Welcome to Physics World. Today we discuss about a new chapter. Before telling the title of the chapter, let me introduce it. Every day in the morning we do so many things, like we walk, we run, we throw a ball, we catch a ball, we hold a book, we hold a pen, we stand. So like that we do so many varieties of things. But what is required to do all these things? Yes, it is energy. We require energy to do all those things. But energy is not the only thing is doing all the things. Energy is the source, but something else making us do all these activities, and that is none other than force. We cannot expect the world without force. If force is absent, I can say that our life is absent. No life exists anywhere. So force is the part of our life. If you hold a book, you are applying the force. You are pushing a table, you are applying the force. You are pulling a draw, you are applying the force. You are walking, running, talking. Each and every situation, you are with force. Force is following you. That's why we need to know more about force. And more than that, we need to know that how to measure the force. In the previous chapter, motion, we discussed what is the speed, velocity, acceleration, etc. But how this type of motions are happening? It's only due to force. So that's why in this chapter we discuss about force and type and the different properties of the force, and we also learn how to calculate it, that is quantitative information about force. That's why today's chapter is force and laws of motion. On the board you are seeing some examples. The examples like pushing a trolley, pulling a draw, compression, compressing a spring, stretching a spring, seesaw. When you go to any park and playground, you can see the kids are playing the seesaw. They are applying the force. Twisting. So in all these cases we have force. And I am not saying that these are the only cases. We have some huge amount of cases. Some examples I gave to you. So let us move on to the actual concept of force. First start with balanced and unbalanced forces. So what is balanced force? Let me draw a diagram and explain you what it is. Take a block of mass m. On this block you are applying a force F1, pushing with the force F1. Now you are applying the same amount of force F2. I have given different label, but it is equal force applying on the other side. Say F1 has the value 1 Newton, F2 has the value 1 Newton. Even though both forces are magnitudely equal, but direction wise they are opposite. F1 is opposite to F2 or F2 is opposite to F1, but still their magnitudes are equal. Then we say that this block is balanced, and the forces are called balanced forces. And in this condition, the block is either resisted or it is in uniform motion. Because when these two forces are acting on the block, which are equal but opposite, but you take the total forces acting on the body, take minus F2 to the left hand side, F1 plus F2 is a total force which is equal to 0, and this is called net force. So net force acting on the body or the block is 0. Then F1 and F2 are called balanced forces. And this situation is called translational equilibrium. Translational equilibrium. That means it is the state where net force acting on the block is 0. And I told you already, in this situation, body is either at rest or in uniform motion. See this example here, it's a marker. Using my right hand, I am pulling the marker, so going towards right side. Using my left hand, I am pulling the marker, it's going towards left side of mine. But if I apply the force equal and opposite, now what's happening? It is a rest state. Still force is applied here. Don't think that I am not applying the force. Yes, I am applying the force, left side and right side, but still the body is at rest. Now say this is in translational equilibrium. And F1, F2 are called balanced forces. So when the balanced forces are acting, net force is 0 and situation is translational equilibrium. Now see some practical examples here. A car is moving towards east. It is moving towards east because of engine force capital F. But there is a friction between the wheels of the car, between the tires of the car and the road. Whenever capital F equal to minus small f, then we can say the car is in uniform motion and capital F, small f are balanced forces. Now in this situation, a person with a parachute is falling towards the earth in the air. Generally, with using parachute, is falling towards the ground means is in the air, is falling in the air. This person has weight, which is mg. Soon we discuss later how we got mg here. So weight of the body mg, because the weight of the body is falling down. But one situation, what happened? This weight of the body is balanced by air friction. Air friction. And you can say mg equals to minus f. The net force acting on the body is 0. And this f and mg are called balanced forces. And situation is translational equilibrium. See the third example, tug of war. This person A applying the force towards him. Say the force is Fa. The person B is also applying the force towards him. Say the force is Fb. If Fa is more, then the B person move towards left side. If Fb is more, the A person move towards right side. If both are equal, like this, then both the persons are in the same state. And Fa, Fb are called balanced forces, and it is in translational equilibrium. So in that we have many examples to understand balanced force. In balanced force, what happened? You cannot bring the change in the state of the body. If you want to bring the change in the state of the body, you need to apply unbalanced force. A car is at rest state, you want to move the car, then you need to apply the force which is different one, unbalanced one, then car moves. A car is in motion, you want to stop the car immediately, then apply unbalanced force. In the two situations, you are changing the state of the body, and it's only happened because of unbalanced force. So let us discuss about unbalanced force. This is also called resultant force. Resultant force situation or unbalanced force situation comes, you have many forces acting on the body, but net force is not 0. Net force has some non-zero value. Then it is called unbalanced force or resultant force. Let me explain more in detail. See the first example. It's a small trolley. The force F1 of 2 newtons act towards east. F2 equal 3 newtons acts towards west. What is the unbalanced force here or resultant force here? So you can see here it is F1 2 newtons, F2 is 3 newtons. Then how to find resultant force? When the two forces are in opposite direction, you take the maximum force, subtract the minimum force from the maximum. So here the resultant force is F2 minus F1. 3 Newton minus 2 Newton, which is 1 Newton. Force is a vector quantity. So it has magnitude and direction. So which side the body moves? So it is 1 Newton towards west. So it is said towards west. Okay, so that is how you are finding the resultant force and unbalanced force. Now see the second example. Now if you want to solve this numerical, pause the video, solve all the numericals and play it again and match with my answers. Now see the second one. If the two forces acting in the same direction, F1, F2, F3 is also in the same direction. So resultant force is here F1 plus F2 plus F3, because all three are the same directions. So 3 newtons plus 1 Newton plus 4 Newton. So the answer is 8 Newton. Which side? Towards east. Now third one. F1, F3 in the same direction, but F2 in the opposite direction. So therefore you take F1 plus F3, total 6 Newton plus 2 Newton, which is 8 Newtons towards east side, but 3 Newtons left side. So therefore this is 8 Newton minus 3 Newton, which is 5 Newtons towards east.